Welcome to the DIY Honda Garage channel. The DTC P0108 indicates a high voltage condition in the manifold absolute pressure MAP sensor circuit. The MAP sensor plays a crucial role in measuring the intake manifold pressure, which assists the engine control module, ECM, in calculating the air-fuel mixture for optimal combustion. Located in the intake manifold, this component helps manage the vehicle's performance and emissions. If the sensor detects a voltage higher than expected, it can lead to performance issues such as poor acceleration or increased emissions. Understanding this DTC is critical in diagnosing related performance problems and ensuring the proper functioning of the engine management system. The DTC P0108 signals a high voltage issue in the MAP sensor circuit, which significantly impacts the engine's operation. The MAP sensor, usually attached to the intake manifold, measures the pressure inside, translating it into a voltage signal sent to the ECM for analysis. When the voltage exceeds 4.49 volts, it triggers this DTC. This fault can lead to an improper air-fuel mixture, adversely affecting engine performance and emissions. It is vital to recognize this issue early, as prolonged operation under these circumstances can exacerbate engine wear and lead to more expensive repairs. Several factors can trigger the DTC P0108, starting with a faulty MAP sensor itself. If the sensor is defective, it may erroneously output a high voltage reading. Additionally, poor connections, such as loose or corroded terminals between the sensor, powertrain control module, PCM, or wiring harness, can result in fluctuating voltage levels. An open circuit condition in the wiring might also prevent proper signaling from the MAP sensor to the PCM. Each of these scenarios needs assessing to effectively determine the root cause of the high voltage error and to implement the necessary corrective measures. When the DTC P0108 occurs, several symptoms can manifest. The most immediate is a noticeable decline in engine performance. The vehicle may experience sluggish acceleration or stalling. Drivers will likely notice the check engine light illuminating on the dashboard, signifying an operational issue that requires attention. Additionally, since the MAP sensor is integral to the air-fuel mixture calculation, increased emissions may also result. Holding off on repairs can worsen these symptoms, leading to reduced fuel efficiency and further engine damage. In the first step of troubleshooting DTC P0108, begin by turning the vehicle ignition to the on position without starting the engine. Using the Honda Diagnostic System, HDS, check the MAP sensor reading in the data list. The key is to ensure that the pressure readings and voltage levels meet the specified thresholds. Specifically, the voltage should not exceed 4.49 volts. If the current conditions align with this threshold, it confirms that the failure has duplicated under these conditions, allowing you to move to the next step. However, if the readings are below threshold, the failure may be intermittent, signaling the need to inspect connections and the PCM terminals to rule out poor contact. Step 2 involves isolating the MAP sensor to determine if it is the source of the high voltage problem. First, turn the vehicle off and disconnect the MAP sensor 3P connector. Utilizing a jumper wire, connect terminals A and B on the MAP sensor connector to create a direct connection bypassing the sensor. Turn the vehicle ignition back to the on position and recheck the voltage on the MAP sensor through the HDS. If the voltage still exceeds 4.49 volts, it indicates that the issue is not with the MAP sensor, but further down the circuit. If the voltage drops to normal, then the MAP sensor is faulty and requires replacement. In the third troubleshooting step, first ensure the vehicle is in the off position before reattaching the map sensor connector. Once that is completed, you will need to check the system voltage to identify any issues with the SG1 line. With the map sensor 3P connector still disconnected, turn the vehicle back to the on position. Measure the voltage between the designated test points on the map sensor and ensure that it is around 5.0 volts. If this voltage is correct, it confirms that there is a proper supply voltage to the map sensor circuit, leading you to the next step. If not, this indicates a depot wiring fault or connection problem requiring additional investigation. Proceeding to step 4 of the troubleshooting process. Again, ensure that the vehicle is turned off before beginning. You will begin by jumping the SCS-SRS short line with the HDS. Next, disconnect the powertrain control module connector C51P as well as the map sensor connector. With both connectors disconnected, you will need to check for continuity between the map sensor's test point 1 and point 2 on the PCM. Achieving continuity indicates the SG1 wire is operational and intact. If continuity is present, update the PCM if it's lacking the latest software version, or consider substituting a known good PCM. If updating or substituting addresses the DTC, then the issue is resolved. The final troubleshooting step consists of checking for a continuity issue along the PB wire. Start by turning the vehicle off once more and repeating the SCS line jump procedure with the HDS. Disconnect both the map sensor connector and the PCM connector C. With the vehicle in this state, measure for continuity between the map sensor's second terminal and the respective test point in the PCM. If you find continuity, the PB wire is confirmed functioning correctly. Any continuity issues may require updating the PCM software or substituting it. If replacing or updating clears the DTC, then all systems are operational, concluding the investigation into the map sensor circuit high voltage error. Upon completing all troubleshooting steps for DTC P0108, it is critical to perform a final verification of the repairs. This involves meticulously rechecking all connections to ensure they are secure and devoid of corrosion. After confirming the integrity of the hardware, clear any diagnostic trouble codes, DTCs, through the HDS, allowing the onboard computer to reset its parameters. Next, conduct a test drive to see if any new codes arise or if the initial DTC returns. Finally, evaluate the overall performance of the vehicle, checking for any immediate improvements in acceleration and responsiveness. Successful resolution of the issue should exhibit a marked enhancement in performance. As part of preventive maintenance to avoid future occurrences of DTC P0108, it is prudent to conduct regular inspections of the map sensor and its associated connectors. Ensuring that these connections are clean and free from corrosion can mitigate voltage-related issues and thereby enhance vehicle performance. Additionally, ongoing software updates to the PCM are vital. Software updates can fix bugs that could inadvertently trigger false DTCs. Establishing a routine schedule for these inspections will foster prolonged vehicle health and minimize the likelihood of high voltage errors arising from the map sensor circuit. In conclusion, understanding DTC P0108 and its associated troubleshooting steps is vital for maintaining optimal engine performance in the Honda Fit from 2015 to 2020. The map sensor is central to air-fuel mixture calculations and directly influences various aspects of vehicle operation. Regular inspections of the sensor and its connections are necessary to prevent potential issues. Thorough troubleshooting is critical, as it helps in identifying whether the sensor itself is defective or if there's a wiring issue that needs addressing. By implementing proper preventive measures, you can ensure the longevity of the MAP sensor and overall engine management functionality. Please like and subscribe to the channel. See you next time.